Welcome to all of you students. Today I am going to explain RISC, CISC and VLIW architecture. This topic related with MSc Computer Science 4th semester. Paper number 3, Advanced Computer Architecture. Unit number 4, Advanced Processor Technology. This tutorial prepared by me. I am Suresh Kumar Thakur, Assistant Professor, Department of Computer Science, Indira Gandhi Government Arts and Commerce College, Vaishali Nagar, Bhilai. So let's take some knowledge about this topic. First of all, we need to start with what is CISC. This is stand for Complex Instruction Set Computing. This is a type of microprocessor design. The CISC architecture contains a large set of computer instructions that ranges from very simple to very complex and specializations. Central Processing Unit architecture operates the capacity of work from instruction set architecture to where it was designed. The architecture design of the CPU are RISC, Reduced Instruction Set Computing, and CISC, Complex Instruction Set Computing. CISC has the ability to execute addressing mode or multi-step operations within one instruction set. It is the design of CPU where one instruction performs many low-level operations. For example, memory storage and arithmetic operations and loading from memory. RISC is a CPU design strategy based on the insight that simplified instruction set gives higher performance when combining with a microprocessor architecture which has the ability to execute the instructions by using some microprocessor cycle per instructions. Hardware designers invent numerous technology and tools to implement the desired architecture in order to fulfill these needs. Hardware architecture may be implemented to be either hardware specific or software specific, but according to application, both are used in the required quantity. As far as the processor hardware is concerned, there are two types of concepts to implement the processor hardware architecture. First one is RISC and other is a CISC. Now CISC architecture. The CISC approach attempts to minimize the number of instructions per program, sacrificing the number of cycles per instruction. Computers based on the RISC architecture are designed to decrease the memory cost because a large program needs more storage, thus increasing the memory cost, and large memory become more expensive. To solve this problem, the number of instructions per program can be reduced by embedding the number of operations in a single instruction, thereby making the instructions more complex. Here we can see the CISC architecture. We can able to see the micro program control memory and control unit, instructions and data path, cache, and this is main memory. And we will load two values from the memory into separate registers in CISC. CISC uses minimum possible instructions by implementing hardware and execute operations. Instruction set architecture is a medium to permit communication between the programmer and the hardware. Data executions part, copying of data, deleting or editing is the user command used in the microprocessor, and with this microprocessor the instruction set architecture is operated. The main keyword used in the above instruction set architecture are the instruction set, the addressing mode. Instruction set, group of instructions given to execute the program and they direct the computer by manipulating the data. Instructions are in the form of code, that is called operational code. An operand, which is the data, where opcode is the instructions applied to load and store data. The operand is the memory register where instructions are applied. Addressing mode. Addressing modes are the manner the data is accessed. Depending on the type of instructions applied, addressing modes are of various types, such as direct mode where straight data is accessed, or indirect mode where the location of the data is accessed. Processor having identical may be very difficult in organizations. Processor with identical and nearly identical organization is still not nearly identical. CPU performance in this architecture is given by the fundamental law. This is the equations and rules where we can find the CPU performance. The CPU performance is depend upon the instructions count, clock per instructions, and clock cycle time, and all the three are affected by the instruction set architecture. Example of CISC processor. One is IBM 370/168. Second is VX11/780. Third one is Intel 80486. IBM 360/168 was introduced in the year of 1970. CISC design is a 32-bit processor and 4 64-bit floating point registers. Second VX11/780 is a 32-bit processor, and it supports many numbers of addressing modes and machine instructions, which is from Digital Equipment Corporation. Intel 80486 was launched in the year of 1989, and it is a CISC processor which has instructions varying length from 1 to 11, and it will have 235 instructions. Now just concentrate over the characteristic of CISC CISC architecture. Instruction decoding logic will be complex. One instruction is required to support multiple addressing mode. Less chip space is enough for general purpose registers for the instructions that are operated directly on memory. Various CISC designs are set up two special registers for the stack pointer handling interrupt. MUL is referred to as a complex instructions and required the program for storing the functions. Advantage of CISC architecture: microprogramming is very assembly language to implement and less expensive than hard wiring a control unit. The ease of micro coding, new instructions allowed, designed to make CISC machine upwardly compatible. As each instructions become more accomplished, fewer instructions could be used to implement a given task. And this is the disadvantage of CISC architecture. The performance of the machine slows down due to the amount of clock time taken by different instructions will be dissimilar. Only 20% of the existing instructions is used in a classical programming event, even though there are various specialized instructions in reality which are not even used frequently. The conditional codes are set by the CISC instructions as a side effect of each instruction, which takes time for this setting, and as the subsequent instruction changes the condition code bits, so the compiler has to examine the conditional code bits before this happens. Now we are in the sequence of architecture, and it is a reduced instruction set. Complex RISC is a computer instruction set that allows a computer's microprocessor to have fewer cycles per instruction than a complex instruction set computer. RISC architecture. RISC is used in portable device due to its power efficiency. For example, Apple iPod and Nintendo's DS. RISC is a type of microprocessor architecture that uses highly optimized set of instructions. RISC does the opposite, reducing the cycle per instructions. The cost of the number of instructions per program. Pipelining is one of the unique features of RISC. It is performed by overlapping the execution of several instructions in a pipelining fashion. It has a high performance advantage over CISC. This is the architecture, hardware control, memory save addition, instructions cache, the data cache, and data part. RISC architecture characteristic. Simple instructions are used in RISC architecture. RISC helps and supports few simple data types and synthesize complex data types. RISC utilize simple addressing modes and fixed length instructions for pipelining. RISC permits any register to use in any context. One cycle execution time. The amount of work that a computer can perform is reduced by separating load and store instructions. RISC contains large number of registers in order to prevent various number of interaction within memory. In RISC, pipelining is easy as the execution of all instructions will be done in a uniform interval of time, like one click. In RISC, more RAM is required to store assembly level instructions. Reduced instructions need less number of transistors in a RISC. RISC uses Harvard memory model, meaning it is a Harvard architecture. A compiler is used to perform the conversion operations meant to convert a high-level language statement into the code or its form. And the advantage of RISC architecture. Reduced instruction set computing architecture has a set of instructions, so high-level language compiler can produce more efficient code. It allows freedom of using the space on microprocessor because of its simplicity. Many RISC processors use the register for passing arguments and holding the local variable. RISC function use only a few parameters, and the RISC processor cannot use the call instructions and therefore use a fixed length instructions, which is easy to pipeline. The speed of the operations can be maximized and the execution time can be minimized. Very less number of instructional format, as a few number of instructions and few addressing modes are needed. We just look over some disadvantage of RISC architecture. Mostly the performance of the RISC processor depends on the programmer or compiler, as the knowledge of the compiler plays a vital role while changing the CISC code to a RISC code, while rearranging the CISC code to RISC code, termed as code expansion, will increase the size, and the quality of this code expansion will again depend on the compiler and also on the machine's instruction set. The first level cache of the RISC processor is also a disadvantage of RISC, in which these processors have large memory cache on the chip itself. For feeding the instructions, they require very fast memory system. Before going to discuss about the VLIW architecture, we can take a snap about the different comparison of CISC and RISC architecture. Just take a tiny look about their concept. CISC is a prominent on hardware, and it's compared to RISC, it is prominent on the software. CISC has high cycle per second and RISC has low cycle per second. CISC has transistor used for storing instructions which are complex, but RISC has more transistors are used for storing memory. In CISC architecture, load and store memory to memory is induced in instructions, and in context of RISC, load and store register are independent. CISC has multi-clock and RISC has a single clock. So after taking the knowledge about the CISC and RISC architecture, we move to VLI architecture. VLIW, very long instructions word instructions, usually 100 of bits long. Each instruction word essentially carries multiple short instructions. Each of the short instructions are effectively issued at the same time. This is related to the long word frequently used in microcode. Compiler for VLIW architecture should optimally try to predict branch outcomes to properly group instructions. The VLIW architecture is generalized from two well-established concepts: horizontal microcoding and superscalar processing. A typical VLIW machine, very large long instructions work machine, has instructions code word hundreds of bits in length, as illustrated in figure. Multiple functional units are used concurrently in a VLIW processor. All functional units share the use of a common large file. The operations to be simultaneously executed by the functional unit are synchronized in a VLIW instructions. The VLIW concept is borrowed from the horizontal microcoding. Different fields of the long instructions word carry the opcode to be dispatched to different functional units. Programs written in conversational or short instructions word must be compacted together to form the VLIW instructions. This code compaction must be done by a compiler which can predict branch outcomes using elaborate. The pipelining in VLIW processor. The execution of instructions by an idle VLIW processor was shown in figure as in front of us. Each instruction specifies multiple operations. The effective clock per instruction becomes 0.33 in this particular example. VLIW machines behave much like superscalar machine with three difference. First, the decoding of VLIW instructions. It is easier than that the superscalar instructions. Second, the code density of the superscalar machine is better when the available instructions level parallelism is less than that exploitable by the VLIW machine. This is because the fixed VLIW format includes bits of non-executable operations, while the superscalar processor issues only execute instructions. Third, a superscalar machine can be object code compatible with a large family of non-parallel machines. On the contrary, a VLIW machine exploiting different amounts of parallelism would require different instruction set. Instructions parallelism and data movement in a VLIW architecture are completely specified at compile time. Runtime sources, scheduling, and synchronization are thus completely eliminated. One can view a VLIW processor as an extreme of a superscalar processor in which all independent or unrelated operations are already synchronously compacted together in advance. The clock per instructions of a VLIW processor can be even lower than that of superscalar processor. Advantage of VLIW processor: increased performance, potentially scalable, like more execution it can be added, and sure more instructions can be packed into the VLIW instructions. Disadvantages of VLIW architecture: new programmer needed, program must keep track of instruction scheduling, increased memory use, high power consumption. And this is the reference where I can found this tutorial material. This is the Advanced Computer Architecture, Parallelism, Scalability, Programmability by Kai Hwang, Tata McGraw-Hill edition. Thank you very much.